Welcome to the programming examples of functions. Programming examples of functions. Now I will try to demonstrate how the functions work. I will also demonstrate that call by value parameter parsing technique. Call by value parameter parsing technique. So start programming. Include stdio.h main, and then this is actually a function. This is actually a function. Okay. Main is also a function. Main is a mandatory function present in the C language. So execution starts with the main. Program execution starts with the main only. So main is also a function. You can pass parameters also to this main. In that case, they are called as command line arguments. We'll discuss it in the last module. So command line arguments. Now suppose I want to add one function, say function1. So what is the syntax? Return type. If the function returns integer, you have to write in int. Otherwise, if the function doesn't return anything, you have to write void. We'll start with void. Again, one word of caution is it may vary from one compiler to other compiler. So there may be minor variation. I never did this programming using this Guinea tool, but let us try. There may be minor variation. Say function1. Let us not pass any parameters. So I will put semicolon here. What does it mean? It is a function declaration. So the name of the function is func1, func1. The return type is void. That means it returns nothing. And there are no parameters indicated by the empty parenthesis. So this empty parenthesis is mandatory. Okay, even if you don't have parameters, you should write empty parenthesis. In fact, this parenthesis indicates that it is a function. Here also you can see main parenthesis. That means it is a function. Okay. Now I will write the code here. Let us just initially add only one printf statement. You are in function. So printf, you are in main function, say, or I will just call it as main. You are in main. Okay. Now if I execute, what happens? Let me save it first. If you execute, what happens? Compilation finished successfully. Execute. You are in main. What is printed? You are in main. So here you can see you are in main is printed. No error message is generated, but you are in main is printed, and you are in function is not printed. Why? Because we have to invoke the function. Why? Because we have to actually invoke that function or call that function. Now what happens? Build, execute. So you can see you are in main, you are in function are printed. You are in main, you are in function are printed. That means you are in main is printed. So execution starts with the main. So the first statement is printf. So you are in main is printed, and then function is invoked. That means you go into the function, and whatever the statements that are present here, they are executed. Whatever the statements that are present here, they are executed. They are executed. Okay. So we'll add another statement, printf, say you return to main. Now build and then execute. So you are in main, you are in function, you return to main. You are in main, you are in function, you return to main. You return to main. So why? So you are in main, function is invoked, so control goes here, this statement is executed. So here this is the end of the function. So after executing the function, where the control is transferred to the next statement after the function invocation. That means the control is transferred to this point. Control is transferred to this point. Okay. So we discussed function declaration. This is the function declaration, function definition, and invoking of the function. And what happens when the function is invoked? This is printed, and after printing, what happens? Control is transferred back to the calling function. Here the main is the calling function, but the control is transferred to the calling function. Control is transferred to the calling function. Control is transferred to the calling function. Let me check whether single mode operation is present or not. Document, search, edit. Okay, same code. I will demonstrate it in another environment also, Turbo C++ environment. What happened? Turbo C++. Okay. Just wait. Return back. We'll do the same program here. We'll do the same program here. Let me just quickly type it. I'm retyping the program. I want to demonstrate something. That's why I'm retyping the program. Just be patient. Let me try to compile it. There are any errors? No errors. Okay, no errors. So what I want to demonstrate here is the single step mode. I want to demonstrate what exactly happens. In the Turbo C environment, you can use what is called as F7 key for single step mode. Let me just press F7. See, I am repeatedly pressing F7. I cannot show it here. I don't have another camera. If I bring this camera again, there will be some issues. So what I am doing is exactly I am just pressing F7. Okay, I pressed F7. Now you can see here that blue line is on main. That means control is transferred to that point. Control is transferred to that point. So you are in main. Okay, that statement is executed. So that this blue bar indicates the statement that is being executed. Now printf that is executed. After executing that one, function 1 is invoked. So here you can see control is transferred to function 1. Control is transferred to function 1. Let just wait. Probably because of colors, you may not be in a position to see. Just a minute. Let me come. Okay. Main. So this statement is executed. You can go here. You are in main. So that is executed. Function 1. Here you can see when we execute that one, control is transferred to the function. And then whatever is present in the function, they are executed. After executing, what happens? The ending flower bracket. So you can see here again control is transferred to the next statement after the function 1. Next statement after the function 1. So that will be executed and that will terminate the program. So here you can see because we have repeatedly executed it. So multiple times are printed, but the statements are printed. You are in main, you are in function, you return to main. So that's how the functions get executed. I will repeat it again. Just observe. Main, printf statement within the main before the function call, and then the function call. When we execute the function call, control is transferred to the function. Control is transferred to the function. And then the function is executed. That means whatever the code that is present within the function is executed. So you are in function that is executed. And then after completing the function, control is transferred to the next statement after the function invocation. So that means you are after this func 1. So the next statement is printf statement. So control is transferred there. So like that the function works. Like that the function works. Okay. Like that the function works. I hope this gave you some clarity about the execution of the functions. Let me try to modify it here. Let me try to add some other function. Say void function 2. Here also I am not passing any parameters. Okay. So you return to main, you are in func 1. Let me modify it. So let me type void function. The color problem may be there. Let me just quickly complete it. We'll go to Geni actually again. Function 2 printf. So I will just read the statements. So I typed void function 2 printf within the function printf. I'm just typing you are in function 2. you are in function 2. You are in function 2. So I close it here. Close it here. You can see here. This is what I have typed. What I have typed. Okay, what I have typed. What I have typed. So now this main can invoke this function 2. Similarly, function 1 can also invoke function 2. Function 1 can also invoke function 2. So let us try it. Printf, you invoked function 2. Function 2. So function 2. Function 2. Let me try again. Okay, you can see here main. You are in main. Function 1 is invoked. So printf, you are in function 1. You are in function 1. Okay, and then you can see this again. You invoked function 2 statement is executed. After that, function 2, when we execute that invocation of that function statement, so again you can here see that the function 2 is invoked. Function 2 is invoked. So like this, you can mix the functions. You can mix the functions. Okay, we'll go back to Guinea again. So that's how the functions works. Now let us modify this one. Let us modify this one. Okay, let us modify this one. Let us modify this one. And maybe I will write a function to add two numbers. Add two numbers. Say function. So because we are adding two numbers, it returns. We are interested in the sum of the two numbers. So let the function return a sum of the two numbers. So because we are interested in integers, so let us assume that it also returns the integer. So integer, say a, integer b. Okay, like this. And here also you can write integer a, b, or integer x and y. Remember, even though you write a b at both the places, but that a b will be different from the a b within this main will be different from xy. Now I will write here xy for clarity. Xy. So the function is like this. Function is like this. Okay. Let me add two variables, say ab. Let me read the values of ab. Enter the values of a and b. Enter the values of a and b. Scanf %d and a and b. So we have written it, and let us remove these unnecessary statements to avoid confusion. So we are going to invoke the function 1. We are going to invoke the function 1, and this is returning. So this is integer. So because this is returning integer, so whenever function returns something, there should be some left-hand variable which is of type return type, which is capable of storing that value. Because here it returns integer, so we should have another variable called, say, c, which is capable of storing the value of c, accepting the value that is written by accepting the value that is written by function, accepting the value that is written by the function. So here, if you want, you can write you can declare a variable. For convenience, we'll declare, say, integer z equal to x plus y, and the function should return. So that is done using return statement. So return z. Okay. So z is written. So that means c equal to function1 with parameters. You have to pass the parameters. So a and b are the values which you have read. So c equal to function1 of a and b, and we are going to just print the values. Print the value of c. The sum of the two numbers is printf, say percentage d, say c. Okay. Now let me try to compile it. Any errors? No errors. So build, execute. Enter the values of a and b, say 10 and 20. So the sum of the two numbers is 30. So what is happening? So you have read the values of a and b, and you have invoked the function, and you have passed the values of a and b, that is 10 and 20. So this function is invoked. We go here. So that means when the function is invoked, x will get the value of a, y will get the value of b. Now a and b are 10, 20. So x will get 10, y will get 20. So within this, you are adding them. Z equal to x plus y, that is 10 plus 20, that is 30. And you are returning z value, that is 30. So when you return the z value, so c equal to this function invocation. So c gets the value of 30. So we are printing the value. So we are getting 30. Okay. This is when function is invoked and function returns some value. You can see the code. Just have a glimpse at it again. Okay, let me introduce some errors. Let us see what kind of errors it generates. Suppose I don't write c equal to here. Then what kind of error a compiler should generate? You can think logically. What kind of error compiler should generate? So it should generate an error message, say left hand value required, or function is returning something. It should store the return value. That kind of error it should return. So what is the actual error? Warning. But it's not generating the error. Actually, some compilers generate the error. So it is giving the error. C is uninitialized in this function. So usually most of the compilers generate error. But let us try to execute it. Will it execute? No, there will be a problem. C doesn't get the value of z actually. So sum of the two numbers is 0 is printed. So because you are not writing a c equal to function1 of ab, so it is returning something. This function is returning something that went to garbage. So there is no left hand variable. So c is not getting any value. But that's why the value 0 is printed. Okay, that is one kind of error. Let me try how this compiler works. Let me put it in the comments. That means I am not declaring the function. What kind of error it generates? Again, it is not generating any error, but warning is implicit declaration of function 1. Let me again execute. But in many compilers, function not declared error will be generated. Again, say 10, 20. So it is not mandatory. In this compiler, it is not mandatory to declare the function. It is not mandatory to declare the function. So instead of, I hope you got the point. Actually, you have to declare the function, because here control goes here, starts executing. When function 1 is invoked, this main or the controller doesn't have any idea about this function 1. So if you pre-declare here, then it will know that it is a function. But in this compiler, it is not generating any error message. So that means, so it is processed and it is storing that there is a function 1 within the same file. So that information it is storing, and then it is invoking. Okay, the other one, what I got to do is, say I am going to cut this, I am going to predefine. So instead of this one, let me try like this. So you can write like this. In this case, actually, you don't require. In this case, you don't require this declaration actually. So here you can see you are not getting the error message, the warning message which you are getting previously. Okay. So it is working properly. So generally, in most of the compilers, you write the function code after the main. Okay, but we will declare it for information sake. We will declare the function for information sake. Otherwise, you can define it before the main. So in that case, there is no need of separate declaration. Okay, that is regarding this different possible errors which you may commit. Now the other one. Okay, function 1 AB. The sum of the two numbers we are printing. Let us print the values of A and B. The values of A and B are, say %d /n. Okay, so within that within the main, what we are doing, we are trying to print the values of A and B. We are printing to avoid confusion, I will remove this statement. The values of A and B. We are trying to print the values of A and B. So A and B are initially 10 and 20. After that, we are invoking the function. When within the function, let us try to manipulate the values of A, this x and y. X equal to x plus 1, y equal to y plus 2. Let us do it. So 10 and 20. Now you are giving the initial values of A and B as 10, 20. After that, you are invoking the function. To the function, you are passing 10 and 20. Within that function, you are manipulating. So you expect 11 and 22. But what is you are printing? I think there is some error. We'll check it. So we expect 11 and 22 are to be printed, but they are not printing. 11 and 22 are to be printed, but they are not printing. 11 and 22 What is the mistake? We are not printing actually. AB, we'll print it. So 10, 20. So here you can see 10, 20 are paused. The values of A and B still remains 10 and 20. They are not modified. Here we are pausing them. We are pausing 10 and 20. A and B we are pausing. But within the function we are manipulating X and Y. But though we are manipulating them, so the values of A and B remain the same. If you want more clarity, you can print here. Printf, the values of X and Y are, say, %d, %d, /n, x, y. So 10, 20. 10, 20. Here you can see the values of X and Y are 11, 22. The values of X and Y are 11, 22. But the values of A and B still remains as 10 and 20. So that is call by value parameter pausing technique. That is call by value parameter pausing technique. Call by value parameter pausing technique. Call by value parameter pausing technique. Okay. Call by value parameter pausing technique. So that means X and Y will be referring to the different locations. So X, Y, A, B. So all these will be referring to different locations actually. So all the locations are different. That is call by value. If it is call by reference, there will be only two locations. X and A will be referring to the same location. Y and B will be referring to the same location. But here in call by value, so X location and A location are different. Though we are manipulating the value of X, the value gets manipulated here. Eighth location value will not get modified. Similar is the case with Y. If you manipulate Y, Yth location will get manipulated. The contents of Yth location will get manipulated. But Bth location content are not manipulated. That's why we are not getting the modified values. So that is call by value parameter pausing techniques. So this is the fundamentals related to the function. So function declaration, function definition, calling the function, executing the function, and then the parameter pausing technique. In the next session, we will discuss some reasonable programs using functions. We'll stop here. So we'll go to the next session where we again continue these programming examples only, but we'll consider some reasonable programs. Not trying to understand just the concept of function, but using functions we will do something. So we'll close here.